Okay, this is the first video for the Function G section of the Functions module. Function G in the module looks at graphing functions, and there are two techniques that can be used to produce graphs of functions. The first is plotting and the second is sketching. In this video we'll look at plotting, and in the next video we'll move on to sketching. Now, when using either technique, it's important to consider any domain restrictions, any division by zero because that's going to result in asymptotes, and any square roots of negative numbers because that's going to result in domain restrictions. Okay, also determine whether the function is of a common form that we looked at in section Functions F, because that will help you because you'll know the known shape and you can use it as a guide, especially when we're trying to plot points. Now, plotting graphs is like a join the dot technique. Okay, it involves using the function to determine points on the graph, plotting the points and joining them with the appropriate line or curve. Now, the ordered pairs of the points are found by evaluating the function for selected x values that you determine. So you need to know something about the function in order to know what x values you want, and they are also going to be determined by any domain restrictions that may exist. Now, a table of values can assist in recording the values, and it's important with this technique to plot enough points so you can determine the correct graph of the correct shape of the graph, because if you don't have enough points you may only be getting a certain part of the graph. Now, plotting can be summarized as follows. 1. Determine any domain restrictions. 2. Devise a table of values considering the domain restrictions. 3. Plot the ordered pairs from the table of values. And 4. Draw an appropriate line or curve through the points and beyond if necessary. If there aren't any domain restrictions, remember the arrows on the end of your graphs. So let's look at some examples. First one here, f of x equals a half x minus 3. You should realize that that's a straight line. Okay, because it's in the form of y equals mx plus b. You should also realize, because there's a positive m value, that your line's going to slope up from left to right. Now, because we have a straight line, there's no domain restrictions. Okay, it exists for all x and y values. So option 1 here is to do a table of values, and this is what we've already looked at in the TM Plus module when we were plotting straight lines. So I pick whatever points I want. Because I have a half in front here, see this half, I'm going to pick points for x that are multiples of 2, so I get rid of the fraction. And in this case I'm going to pick -2, 0 and 2. Reason being that I get both sides of the axis, see what's going on. So f of -2, if I plug -2 into here, I get a half times -2 minus 3. Half times -2 is -1 minus 3 is -4. So my first point is -2, -4 in brackets. Always do 0, because you'll note when you plug it in, whatever's with the x just disappears. So I'm left with that -3. And then with 2, f of 2 is a half times 2 minus 3. 1 minus 3 is -2. So when I come across and plot, I have -2, -4, 0, -3, and 2, -2. And you can see that those 3 points line up. So when I try and draw my graph, excuse me if this is a bit wobbly on the computer screen, it's not that bad though. Remember to label it. F of x equals a half x minus 3. You'll also see that I have my axes labelled as well, so remember that if you're drawing it from scratch. Now, the second method is the intercept method, where we're finding x and y intercepts. So that's going to be x is 0 and then f of x equals 0. So when x is 0, I get f of 0 is a half times 0 minus 3, which is simply -3. So that's my first point. When f of x is 0, I get 0 is a half x minus 3. Add 3 to both sides. 3 equals a half x, times both sides by 2. 6 equals x. So 6, 0. And you'll notice when I come across, there's the x-intercept, there's the y-intercept. Okay? A lot easier, I think. And also remembering x and y-intercepts are going to be critical values, so you need to find them for any function anyway. Next one, f of x equals x squared plus x minus 6. Now you should note from this one, squared term here, so we're looking at a parabola. Now parabola doesn't have any domain restrictions. It exists for all x values. Okay, another thing, helps if I can spell, no domain restrictions. Another thing, because there's a positive at the front, it's a happy parabola. So we're looking for something like that. That helps before we go to our points. Now, where do you start? This is what the problem is with this method. You could be going on forever trying to find points to get your parabola. So I already know what it looks like, which helps me. So I'm going to look -2, -1, 0, 1, and 2. Okay. No, it's not a Rembrandt that I'm trying to create here. I'm just doing a rough table so I can figure out what values I've got. F of -2 equals -2 all squared minus 2 minus 6. Remember that's in brackets because -2 all squared becomes +4. So the answer is -4 and my coordinates -2, -4. F of -1 is going to be -1 all squared minus 1 minus 6, which gives me -6. Always do 0, because you'll note when you plug it in, 0 squared minus 0 minus 6. You're just left with that intercept. So 0, -6, 1. F of 1 is going to be 1 squared plus 1 minus 6, which gives me -4. And then 2, f of 2 is going to be 2 squared plus 2 minus 6, and that's going to give me 0. Now one thing I have noticed here, these values are the same, so the turning point must happen somewhere in between those 2 points. So -2, -1, sorry, reading the wrong thing, -2, -4, -1, -6, 0, -6, 1, -4, 2, 0. Now I also know that my other x-intercept is going to be over here because a parabola is symmetrical. I also know my turning point somewhere in here, and I could work out that exactly if I plugged in x as a half. But then I'm turning into the other technique of sketching. That's pretty dodgy. So you get something looking like that. Note that I'm making that turn not look like a corner, and I have to label it f of x equals x squared plus x minus 6. Okay, another one, f of x equals 3 over x minus 4. I know that's a hyperbola because I'm dividing. Okay, so that means there's going to be a domain restriction, and that's because my denominator there can't equal 0. So x minus 4 can't equal 0, x can't equal 4. I also know by swapping these two values around that I've got a range restriction. Okay, hyperbolas do have x and y asymptotes, so that x can't equal 4, that's my one asymptote. By swapping these around, I also know that f of x can't equal 0, which is my other asymptote. Okay, so if I label those asymptotes on here, I use a dotted line, keeps going, x equals 4, and my other one's on the axis, so I'm using a different colour so it stands out, f of x equals 0. Now, table of values is very tedious for a hyperbola. Okay, you need to do a lot to get to it. Look to the textbook for that, because I'm going to take ages on this video to explain or go through the points. You can see it quite easily in the textbook, so refer to the textbook to see that table of values. Personally, I wouldn't go there with a hyperbola. Like, I know that a hyperbola, in this case because it's a positive out the front, is going, that's my basic graph for hyperbola. I actually have enough information right now to go, okay, so that's going to be somewhere in there. And this here, oh, okay, I need my y-intercept to know where it's going to go. So f of 0 is 3 over 0 minus 4, which is -3 over 4. So that's about there. So I know that this one's going to look like that. Okay, that goes a bit further in, so I might come back and make that go a bit further in there. Okay, and then I have to remember to label. So instead of doing the plotting method here, I've kind of shown you the next method, which is sketching, and hopefully you'll see that it's a lot less tedious. I would also put in that that's 0, -3/4. Okay, the key though to be able to do sketching is that you need to know what the graphs look like. I need to know that a hyperbola looks like that. If I don't, then my only option is to plot. So what to do now? Look at exercise function G1 and use a plotting technique to do that exercise so you know how to do points. If you don't know what a function looks like, what the graph looks like, plotting is your only way. Okay, then move on to the second video.